tricky one that you're going to write up as for the exam. So oops. So to measure velocity, the speed of the river, you're going to need quite a few bits of equipment this time. One of these, this is called a hydroprop staff. Hydroprop staff. It's made of brass, so it doesn't rust. It's got little lines on it indicating depth, 5, 10, 15, 20. They're all in 5 centimetre chunks. And it also has a little slidey thing on it, a little clamp. Okay. Now onto the clamp, you need to fix the next most important bit of equipment, probably the most important bit of equipment in your bag, which is in this little case. This is called an impeller. Okay, so we've got an impeller, I-M-P-E-L-L-O-R, and the impeller is going to screw onto your clamp. So you just screw it on there. Make sure that's all the way to the end. Sometimes they stick on the end, so I'll just give it a little tweak, just make sure it's turning, and then it'll work properly. You're then going to measure the velocity of the river. Can anyone suggest where I should do that? Go for it. Where you measure the depths. In an ideal world, I would agree, Henry. Every single time you measure all of your stuff at the peg you can measure. It takes quite a long time to do this, so we're cutting it down to only 3. So we're only going to measure it 3 times. Any thoughts as to where? If we only got 3 places to pick from? Quarter, half, 3/4. Well done, Lucy. So you're going to go quarter of the way in. I'm happy for you to do that by eye. Quarter of the way in. You then need to figure out where you would like to place your impeller, at what depth. So you can have it at the surface or at any depth in between. Where should we set it? We're only going to take one reading of the velocity.
Middle.
The middle, well done. We're going to set it at mid-depth, about half of the depth. Why the opposite for the middle, Lucy?
Because it's where the average.
Well done. It's about average water speed. The surface, fastest or slowest at the surface? It tends to be fastest. Depends on the weather conditions. If the wind is with it, it's certainly even faster. But generally speaking, you're away from the bed and the banks, you're away from those rocks, the friction is going to slow it down. So it's the slowest at the bottom, usually. Fastest towards the top. And about mid-depth is approximately an average speed, a good average to go through. So the first thing you need to do, lift this little clamp out of the water, find your halfway point, stick your hydro pump down, and then you're going to take your finger, run it down to the water level, and then you're going to lift up to see the depth. So the depth here is almost 20 centimetres. So you're going to need to set this halfway deep. So I'm going to set it about 9.5. Run it down just below 10. Turn the little clamp, and then it fixes it in that spot there. Let's get that back. You're then going to have someone on the riverbank with a stopwatch. I'll pass the stopwatch over to Ellie. Nice one. So we're going to try and get in synchrony here, because if it goes in first and then Ellie's a bit slow or I'm a bit too fast, so we're going to try and ensure that it's nice and in time. I'm going to hold on to this, stick it in the water. Are you ready, Ellie? Yeah. After 3. 1, 2, 3, go. It's important that you hold this nice and still, nice and straight, so the impeller's looking straight upstream. It's also important as to where you stand. Think what might happen if I was to stand there instead of here. Yeah, I'll be obstructing the flow. There may be other groups in the water, so that's an evaluation point for you later. There's other groups, they're going to be impeding the flow. We're nearly there. 3, 2, 1, stop. Okay, and so we've got it. We've timed how long it takes for the impeller to be pushed all the way to the end. we were trying to work out the speed then, how would you do it? Times, what do you think, Henry? Well done, it would be distance travelled divided by the time. Now, rather than have you guys work that out, it's already been worked out for you on this graph. We've got a velocity conversion chart here. So that's the final thing. Using the speed equals distance divided by time formula, what was the time it took there? 31.02 seconds. So you run along here, 31 seconds, go up, and then across the way you could use a ruler. You could work out it's approximately 0.14 meters per second, 14 centimeters a second of water going past. Does that look about right? 14 centimeters every second, something like that. Does look about right. So we've got the velocity measured then. Running through a few of those points then. Important that you stand downstream, not upstream like this. Important that you hold it nice and vertically, not sort of back and not sort of to the side. It's no good. You then go along to halfway and you're going to do the same again. So you're going to hold on to it, place it in the water. If you don't hold on to it and go 3, 2, 1, go, it's kind of already started to shift as it goes in. So by holding on to it, you then try and ensure that the start and stop is at the same time. If there's a big rock in the way, what are you going to do?
Leave it.
Leave it. Yeah, don't move it. And then, yeah, it's really fast. The speed of the river at that point will be slow because big rocks. So leave everything as it is. Sometimes it'll be so slow that after a minute it won't be actually at the end. It'll still be churning round. After 1 minute you can just stop timing because you might be there for hours and the graph only goes up to 60 seconds. That's partly due to the fact that the velocity tends to level off anyway around about 0.08 meters per second. But also in very, very slow flows this device doesn't work very well. It's not sensitive enough to be pushed by very, very slow flows, slower than 8 centimeters a second. So that's another evaluative point that we'll come on to a bit later. Just in case you stood there and it's like, 5 minutes gone and it's gone that far, just stop at 60 seconds. Make sense? Perfect. After you've done that, you can take off the impeller, pop it back in its little case so it doesn't get trodden on or anything, and then that bit's done. The final measurement that we're going to do comes to what Lucas said earlier, which was the wetted perimeter. Okay, that's your final